Okay, sorry, this took more time than expected. That was the whole reason we actually chose this room so that we could have Zoom and like a hybrid environment so that we could have Zoom and teaching at the same time. But I don't know how this works. I've tried so many times, still doesn't make it work. So I'm using my ear headphones. So I hope everyone can hear me on Zoom fine, even though I'm moving away from the camera. So regarding the last class, the lab, did you have any issues with the last lab? Did anyone, any questions, any complaints? No? The last lab was supposed to, it was supposed to just give you an idea on how to install Zoom, not Zoom, sorry, Python in your environment, how to set it up. There are many of you who know how to set it up, who you have experience from before, but there are a few of us who never have worked with Python. So it was just for them to get the environment up and running, and so that we can use it for going for further development in the class. So if you have any issues, if you have not been able to figure it out, please come forward and we'll help you out. That environment is needed because the next labs will depend on those, that environment. All right. Let's see what the chat says. Okay, still everyone can hear, so that's good. Okay. So today we're going to talk about data. It's very important to understand data because AI, I mean, all AI algorithms rely on data. So that's the difference between simple development and AI development, is that when you are done with normal development, your output is some sort of data which the users can see. But in AI, you have to combine the algorithm with the data, and then your output would be a prediction score. So data is very, very important for the AI algorithms. So we have allocated 2 lectures for data only. We'll talk about how to acquire data, how to clean data, how much raw data there's available, how to clean it, different kind of cleaning strategies, or it's done different kind of data fields. Of course, we're not going to get a specialist on data, but we're going to just go through it. Just to give you an idea, we had an AI lab run at Router from June to August. And we had 4 students come in who kind of took one of the use cases. And one of the use cases we wanted to work was to predict when the bus will come. It was called estimated time of arrival. So we used like machine learning. We took like the historical data for the previous journeys, and we fed it to the algorithm, and we came up with a very good prediction score. But the biggest thing the people worked with in the 3 months they were there at Router was data cleaning. And it came to them as a shock because for us who have been working in industry for a while, we're used to this. We know that most of the time will be spent on data. But when these came out from the university and they were given like a practical use case to work with, this was the feedback they gave us. Like, it was very shocking for them to know that almost 2 months of their time was spent with data cleaning. We gave them access to the data, but the data was, you can't just use data as is into your AI algorithms. You have to clean it. You have to add more features to it. So 2 months out of 3 months was spent with data. And still, we kind of took away a lot of features in the end because we were like, now we have to finish off the algorithm. So I mean, it's important. Data is very important. People don't want to work with data because that's the most boring part of AI. The exciting part is the algorithm, but that's one of the biggest requirements to work with AI. Okay, let's see. There are, I mean, if you're supposed to, if you're given the chance to work with an AI algorithm, and if you have to identify that, how would you do it? How would you define an AI algorithm? So yeah, first thing, of course, the problem, the use case, what's the problem you have to solve. You then have to start looking at the data. So if I come to you and I say like, hey, I need you to work on an estimated time of arrival algorithm for the router, and I want you to predict when the bus will come. So right now we have an estimated time of arrival. So the bus is supposed to come at 5 o'clock. That's an actual time of arrival, but then there's also an estimate. For example, there can be many delays along the stop line, right? There could be an accident, there could be a traffic delay, there could be perhaps it's snowing, perhaps it's raining. There's more crowd on the platform, so there are many factors which can affect the actual time of arrival. So then we get a new time, which is called an estimated time of arrival. So what we need to do, so the algorithm needs to identify when will the bus come. That's called the estimated time of arrival. So I come to you and I give you this task, like make this algorithm for me. So the first thing you will do is, after understanding the problem, you will ask me about historical data. So you will ask me what kind of data is available. So then I'll give you all of the historic data we had. So the historic data can be 1 month old, it can be a week old, it can be a year old. That is vital for you to make sure that the algorithm succeeds. When you have the data, you will then clean the data. There would be a lot of duplicate entries, there would be a lot of missing entries, there would be a lot of garbage data inside that data set. You have to clean it and you have to make sure it's usable enough for your algorithm. Once that is done, then you will choose the algorithm. And there are different algorithms to work with. You might have to use supervised learning, non-supervised learning, regression algorithms. We'll discuss all of the algorithms in this class. And once you have identified the algorithm, you then train the algorithm with the data, you execute your AI algorithm, and you see how the output is. The output is a very important part because the output is actually a prediction score, which tells you how good your output is. How to explain it? For example, in the estimated time of arrival, what you're trying to predict is there's a scale of when the bus will come. And for every scale, there's a percentage associated. And the prediction rate having the highest prediction output will be the one which will win the time slot. It's easier if I show you rather than actually talk about it. Okay, so once you train the algorithm and you run it with the data and you get like a good prediction score, you then have to deploy the algorithm on a selected platform, and that's it. Then you have an AI algorithm running fine. Now, how is it with general software development and AI software development? Now, in a general software development, it's the other way around. You come up with the problem, right? Problem is common for everyone, but then you identify which language should you use or which environment should you use to solve it. Once you have identified that, you then create an application. And once you create the application, you then produce data, which could be anything from, like, for example, if you're creating an e-commerce application, your application would be done in Java or C#. And then once you create the website, you then start storing all the information of users inside a table, inside flat files. That would be your storage, and that's your data. That's the data about your customers. In AI software development, you have to forget everything about that, because that's not how you do it. You look at the data first. What historical data will I use? And then you have to figure out, all right, with this data, I need to produce this specific thing. Has anyone heard of AI being used in stock market prediction? Yeah, okay, good. So what we do is in stock market is that, I mean, the price goes up and down every day. So a lot of statisticians and AI developers have tried to use AI and statistical modeling to try to predict the value of a particular stock on a particular day. And so what they do is they take historical data, and what are they trying to predict? They're trying to predict what will be the price tomorrow, or what will be the price in an hour, or in the next 15 minutes for the specific stock. And that's the input data, the historical data, and the output is actually the price which they're trying to predict. So I mean, the output is also from the historical value, right? So the output is never going to be a number which never existed in the data before. Another example is, if you are trying to make an app which distinguishes between a cat or a dog, your historical data is cats, images of cats and dogs, and your output will also be either cat or dog. So your output cannot be a human or some other thing, because the historical data set contains all images from cats and dogs. So the output should only be coming from the input you have assigned. So you have the input data, and then you know what kind of desired output you need, and then you apply the language part on it. You create the application, you generate the output, and yeah. But again, the biggest difference is, then if you run the process once and you realize you have not reached your desired output, you have to rerun it. You have to look at the data again and see if there was something wrong with the data, improve the data, clean the data, add more feature sets to the data, run it again. If you reach your desired output, good enough. If not, then look at the algorithm. Do you think there's something you could improve or tune on the algorithm part? Do that. So you have to continuously look at two different areas and try to improve over there. So what's important in AI is assigning a benchmark. What's a benchmark? Benchmark is, so for example, for you, a benchmark for students, a benchmark would be, you're taking a bachelor course, and your benchmark is, if I am able to pass all of the courses, and if I can get a degree in 4 years. Is it 4 years or 3 years for you? 3 or 3? Yeah, 3 years. So your benchmark is like, if I can get a degree in 3 years, that's good enough for you. Your benchmark could also be, I need an A in all of the courses, and only then I will be happy enough to say that I've completed my bachelor's. Everyone has a different benchmark for themselves, right? So you create the same benchmark for your algorithm. Like in Router, when we worked with natural language processing, our benchmark was that if our algorithm can give a prediction rate of 80%, that's good enough for us. We don't have to achieve 85%, 90%, or 95%. It gave us a prediction rate of 85, so that was much better for us. But the thing is, with AI, it's very easy to get the first 80%, or the first 85%, or the first 90%. But if you want to improve the algorithm and you want to make sure that you kind of increase the efficiency of the algorithm from 85% to 86%, that's very hard, because you have already completed, you have the data set, you have the algorithm. Now it's very hard to improve the data set, clean the data set, enrich it with more features, and kind of check it with different algorithms. That takes time. It can be done. I'm just saying it takes time. How likely is the outcome? I think I skipped the question. I didn't understand the scope of the question. Okay. So yeah, I mean, AI is about algorithms, tools, and data. Has anyone tried Kaggle here? Kaggle, have you heard of that, Kaggle? So it's I mean, Kaggle or Kaggle, I don't know how you pronounce it, but check it out. Kaggle is a very cool, I wouldn't call it a website. It's a competition platform. So people who are learning machine learning, they go to Kaggle, and they can find like data sets already available. So you can download a data set. You also have examples of how to create a machine learning algorithm around it. So what this platform does is Kaggle actually has a lot of competitions. So they announce competition between machine learning engineers. So if you want to try something out, you could probably go to create something good and also win some cash over there as well. It's very popular amongst a lot of machine learning developers. Sometimes if you go for a job interview, they will even ask you if you have a Kaggle account. So the higher the score on Kaggle, the higher the money you can get in an interview. Yeah, and I mean the programming languages which you can use to do AI programming, they are Java, C, C++, Python, Scala, yeah, R and Go. And then there are frameworks on top of them. So you might have heard of TensorFlow. You might have heard of, have you heard of TensorFlow? Yeah, okay, good. For those of you who have not, we will cover that going forward. TensorFlow is a very good framework by Google, which you can use to actually create machine learning or deep learning applications. Then you have a lot of frameworks. You have H2O.ai. This is also very famous. There's one called I've forgotten the name, but it's a drag and drop. So what you do is like simple terms, like we use Python or use Java, we write the code. But in that framework, it's like a user interface based tool. So you just click, and it will take the data, will generate the model for you, and you can put it into production as well. There are a lot of those available nowadays. Okay, so let's talk about data. What they say about data, this is probably something you've heard, that a lot of companies, not companies, a lot of people on the net are claiming that data is the new oil. That this buzz sentence started some while back, and everyone started saying like, oh yeah, we have to move away from our simple economy, or we have to move away from our oil economy, and data is a new economy. And then you had articles coming in like the world's most valuable resource, and that's not wrong. I mean, we are living in a data economy. Can anyone tell me how are we living in a data economy? Any one example? Yeah, sure. Good point. Yeah, very, very important. Anyone else? Anything about data economy? Yeah. Oh, marketing in general. That's place on data. How do you think data is used there? Yes. Yeah, absolutely. If someone else raise a hand over, yeah. I'm sorry. Political influence, yeah, a huge factor actually. Yeah, so I mean, this is a data economy. You have ads based on how we behave online. We have our profiles, and that's why we have GDPR which came in. We had a lot of data regulations trying to protect our data. This is a data economy. So I mean, if you make an application which is not producing data which can be consumed by other services, then there is a problem. Because or actually, you know what, there was one example which wasn't related to data economy at all. So I was in TechCrunch. Do you know what TechCrunch is? TechCrunch is like a gathering, it's a conference, it's a seminar, it's based in US and based in Berlin as well. So it's a gathering of all startups and all founders who come together. Startups pitch their ideas, and the VC funds, they kind of invest in them. So they have a panel where people present their ideas as well. So they had a competition of different startups presenting their ideas, and I mean the best of the best startups win that competition. And that was in 2018, just before the pandemic. And one of the startups which won, so every startup over there, they were either talking about blockchain, cryptocurrency, they were talking about artificial intelligence. A few of them also focus on quantum computing. Like all the buzzwords were there. And it was kind of hard to pick about who was doing the actual work. But the startup which won was a startup which was, they had a very simple idea, not related to data economy. I'm just sharing this with you. This was, I found it very interesting because all of the startups were focusing on, hey, we collect data, we sell data, we collect data, we do this, we collect data, we use AI, and we collect data and we put it on blockchain so it's secure, everyone can see it. And then one startup came in and they say that we have made a website for men to freeze their sperm. And people were like, why do you need to do that? This already exists. And they said that, yeah, this exists, but there's a huge, like when it comes to male and female, it's hard to convince men to take that path when it comes to freezing their sperm as compared to female who would freeze their eggs. And they said that women are naturally more prepared to take this step and men are not. So for us to convince men to freeze their sperm, we made a website which was very manly. And they showed their website. I don't remember the name of that website. I'll dig it up. So you open the website and there's a guy which has like this rough face and a beard. And that was a manly thing for them. And they were like, men will feel more comfortable going to this website. So the focus was on user interface. And then they were like, if you go there and you order, we'll send you a tube home so you can submit your semen in it, and then we will store it. And that was such a simple idea. This exists. I mean, a lot of hospitals do it, a lot of clinics do it. But just because it was a tech service, that started one, and they got like, I don't know, $50,000. And then if you win, then a lot of VCs will come and sponsor you. And that became very famous, actually. So this is an example of not using data economy. So people ask them like, how are you using the data? And they're like, we're not using data at all. We don't mind data. So they're like, do you sell ads or do you sell the data somewhere else? They were like, no. So, I mean, yeah, we're living in a data economy. Most of the services around us will use data, but then we will end up seeing some of these examples, which are very unique, very simple, which solve like the simplest problems around our lives. And which won't use AI, which won't use blockchain, which won't use crypto, but still they will sell. Yeah, so privacy, so that's what Europe is trying to do. That's what California and UK is also trying to do. So you have three data regulations around privacy. You have GDPR by Europe. You have CCPA by California, and there's one more by UK. All of them are based on data regulations. And they're around data privacy. For example, in Europe, at least, it's not allowed to identify a person using an AI algorithm through a camera. And that's one of the reasons you don't see a lot of cameras, just even for security, you don't see them. So even for Svare in Norway and Kripos, which is like the intelligence agencies of Norway, even they're not allowed to use that. So there's a huge focus on data privacy. So being a citizen living in Europe, being a person living in Europe, your data rights are more protected as being a person living outside Europe or somewhere else. But being on the other hand, being a startup and working in Europe is much harder than being a startup and working in other countries. It's easier to make algorithms around those. So you cannot enforce privacy on AI, but you can enforce privacy on the data. That's what they do. So regulators, they enforce privacy on the data. So if you restrict the data sets that no personal images will be allowed in data sets, then you can't make an AI algorithm on it. So the way to get around is we mask it. We try to recreate another person, or we just take away the face altogether. Depends on the use case. Okay. Legacy.com. I'm not sure. I need to check this. If it's legacy.com or not. Okay. So, I mean, something happened around this time, Internet of Things. Internet of Things became very popular 5-6 years ago, even before AI. What is Internet of Things? Internet of Things is anything smart connected to the internet. You had smart heaters connected to the internet. You had your smartwatch. You have your phones. That's also Internet of Things. So we started producing a lot of those electronic devices, which started producing a lot of data, which was consumed by the internet. So then we had an explosion of data. Everything was producing data. And then, of course, social media as well. Anyway, so let's talk about daily life of an AI programmer. What would you do if you are an AI programmer? So 80%, around about 80% of your time we spend on data. You will do data cleaning, you would do data wrangling, you would do data mining, you would do data warehousing, you would do feature engineering, you would do a lot of these things with data, just data. That you could do that in Python, you could do that even an Excel file, you choose. And then 15% of that time will be programming the actual AI algorithm. And then 5% would be deploying that algorithm. Now, it's one thing to make an algorithm, but it's another thing to make sure it works in production. So deploying is actually a very big part as well. We can deploy it on your computers, but cloud is actually a preferred way to do it. So what does it mean? It means that an AI engineer, when companies go out and look for an AI engineer, nowadays, no one looks for an AI developer. No one looks for a machine learning developer. They look for a person having a profile of a software programmer who knows how to deploy, who knows how to do all kind of programming things, how to make a script. Then they want to see if the person knows data engineering tasks. The person can work with data, transform data, clean data, and the person can also work as a machine learning programmer. So that part, machine learning programming part, is a very small part. And the more people I talk to, everyone kind of gives me the same kind of feedback because they're looking for a full stack developer. Do you know what a full stack developer is? Yeah, okay. So they're looking for a full stack developer who can do everything plus do machine learning as well. It's becoming a bit hard to be a developer, general developer, I would say. Like it was easier a few years ago. There weren't so many frameworks, but now when you graduate, it's expected to know a lot of things. And our universities don't really prepare us for those kind of frameworks when we graduate. I had the same problem. I hope you don't have the same problem. And when it comes to AI, I think AI is so hard to work with that, I mean, no course can prepare you for what has to be done in practical. So when you, I mean, do not expect you to be specialist with AI when you take introduction to AI or advanced AI course or any other course. But be fine with the fact, be comfortable with the fact that you know how things work. You just need to know concepts. And we're living in a world where no one is really an expert at anything right now. You need to know a bit of this and a bit of that. And then you learn with your peers. Unless and until you work in a startup, then you work on your own. But I mean, most of the companies, they just, I mean, you come in as a junior developer, you're assigned a senior developer who kind of becomes your mentor and they teach you. And then you have a team and you make mistakes and that's fine. And it's a repetitive process until you become more valuable. So let's talk about different problems which can occur with data. Oh, it's a break. Let's take a break, 15 minutes break, and come back at 3:30. Right. Can people on Zoom see the screen fine? I changed a few things. Yeah, okay, great. Thank you. So the most important problems, the biggest problem that can occur with data, this is called data pitfall. And like you or we assume that the data is clean. Data should be clean. I mean, we're getting a data, we get a file from someone. We're like, yeah, they'll probably have taken care of most of the things. But I mean, the most common of them is like spelling mistakes. For example, this is the data set compiled from an address information. Um, like you would probably, if you make an application or someone has already made one, which compiles lists of all the customers with their address information, people can make mistakes while typing it in. So the most common we saw was like we just took a dump of all the address, and by when I say we, I'm like the developers took a dump, and they found like this is a very common example. Like the city Philadelphia is written is there's a lot of mistakes just on the city itself. So if you see that, you have to fix it. You have to make sure you clean that data set by assigning like a new value to it. Was better before break. Okay, outliers. What is an outlier? Let's see, where is it? Information? No. What is an outlier? Outlier is outlier. How should I actually? So something which does not belong in your data set is called an outlier. Um, um, let's see. I have an example written down. Give me 1 second. This is the most useless computer I've ever used. I am so sorry for the delay. This is very frustrating. For you, I'm sure for you as well as for me, but I mean, this is very strange. Okay, anyway, uh, I just had to open up my notes. That's why I had to go through all this. Um, so what really is an outlier? If you look at an outlier, if you make a web application, right, and they all of when you release the application and you see like, hey, there are 20, as soon as you release, there are 20 people or 20 active users on your platform, and you're very excited, like, as I just released my site and there are 20 people on it. um, but you need to see where that traffic is coming from. Now, if that traffic is just bots, there are many bots on the internet, they're just doing a click on your site, or these are people, your friends and family members, that's an outlier. You wouldn't consider it as your main users for your data set. Um, so in your data, you have to consider what your outliers are. Um, Again, another example would be your website is going very well. You had like 20 normal users, but then the next day you had 20 more users signing up. Now, in a statistical form, this will be a growth of 100%, but in actual real numbers, it's only 20 more users signing up. But if you talk to a VC and you say to them like, hey, my platform had 100% growth in one day, that's an impressive figure. I mean, that's a very good figure to say. But if you look at the data, so I mean, percentage wise, it's good, but data wise, it's very small, right? It's like 20 users only. So I was talking to this like investor who had bought some Tesla shares, very optimistic about Tesla, and he was like, "Yeah, Tesla is a growing company and all that." And then he presented some interesting data, and he said, like, "Look at the growth. Tesla is a growing company, right?" It said it's a good brand in the market. People buy it. And then he said, like, look at Germany. Germany is a growth of Tesla from in the last quarter. There was an impressive growth of almost 1,500%. And that is impressive. I mean, as a shareholder, you'll be like, hey, this is a huge growth. You don't see the same growth in Volkswagen, for example, or any other car brand. So he was like, he was trying to convince everyone, like, you should buy more Tesla shares. But then we looked at data, and yeah, the quarter wise, his perception was that Germans are going crazy over Tesla. Everyone is buying 1,500% in 3 months is actually very impressive. But the data showed, like, if you looked at the numbers and if you compare the number of cars sold by Volkswagen in Germany in the last quarter. So Volkswagen had a growth of almost 20%, and Tesla had a growth of 1,500%. But if you see the numbers, Volkswagen number of cars sold by Volkswagen in the last quarter was around 200,000, and then they increased that by 20%. And the number of cars sold by Tesla was 14,000, and then they increased that by 1,500%. So data-wise, it's wrong to say that Germans are going crazy over Tesla. They are not. They're still buying Volkswagen. But Tesla, as a company as a whole, they had an impressive growth. But it doesn't mean that a lot of people or everyone is buying Tesla. That's not true. There are a few people who are buying Tesla, but most of them are still buying Volkswagen. But then it comes to the fact that you, as a shareholder, where would you put your money in? Most of us are ordinary people. We do not go inside the math. We do not go into looking at the details of the data. So most of us will go with a narrative like 1,500% is an amazing growth, and we will buy the stock. But for the few of us who are actually smart enough, they won't buy the stock. But the problem is most of the growth in the stock market nowadays is because of all the stupid people who keep on buying and pumping the value, and the stock keeps on going up. And that's where you get the meme stocks and the rally stocks. And then the smart people kind of miss out on all the growth which is happening on the stock market. So it's two ways to actually see it. Buy high and sell low. That never works. Okay. It's very important to look at your data. For example, there are seasonal factors you would like to include in your data. A very good example will be router again. Like, we know that when it's Easter holidays, like when there's summer holiday, right? There are not so many people inside Oslo and weekend. They're not taking the public transport, so we cut down on the public lines. But when there are holidays like shopping holidays, like Black Friday or the Christmas, what's that called? Do you know what's called like the Christmas shopping? It's fine. So, but let's take Black Friday as an example. That's one of the most biggest shopping events inside Norway, or actually around the world. So we know that when that happens, the traffic spikes for router. So we see a huge spike in traffic. So when we are providing our figures or when we are creating our algorithms, we exclude those days, because that data is anomaly. That is like an unusual pattern in the data. COVID, for example, COVID is a huge anomaly for us. Why is COVID a huge anomaly? Because we had a regular number of passengers taking router services, and all of a sudden COVID came and the government announced everything is being locked down. You cannot leave your house. You should not go to work. You should not go to school. Everything's shutting down. Everyone started canceling their routers tickets, and that's fine. But then the passenger numbers went from a 70% capacity to 5% capacity. And then you had trains and buses which were running on empty. Now, when we have to look at creating our models, this COVID time was a huge anomaly for us because it's not only for one day, it's not for a few weeks, it was for one full year. And then that is hard because we don't know what to do with that data. Should we include it? Should we include it? It's so big. It's actually 1 year, but I mean, it's now has become part of the business because everyone knows COVID is there. Everyone knows the income of the company will go down. So for that specific event, we don't know what to do. Should we take away data or not? But for smaller events, which span over a few days, few hours, or a few weeks, we just take them away. We try to reproduce the data with stable numbers. So stable data is the best data you can use for your algorithms. Unstable is the worst one. Yeah, context. Context is very important. Context, why is context important? Because when you, let's take the example of your e-commerce application again. You created the application, and as soon as you launched it, you send it to your friends and family. And then you probably had 100 users signing up on day one. But the context is that you told your friends and family, and they signed up because they believed in you and they believed in your idea. But the real users are not those 100 people. They are probably the people who would actually need your service, and they will come in like a week or 1 year or a few months. We don't know. So when you tell the story and say like, hey, my application got 100 users on day one, that is wrong, because the context says that you convinced them, or they came in just because they wanted to support you. They are not the actual users of the platform. So yeah, context is critical when you want to report growth of your service. Yeah, I mean, a lot of companies are struggling with this. They are struggling with having like, they don't have good insights into their data. There was data is a new oil, which was the new buzz sentence going around. Now the new buzz sentence going around is data insights, making the company a data-driven company, making a company an insight-driven company. A lot of companies do not have the insights. They have a lot of data. And what they want to do is they want to import as much data as possible, which is the wrong thing to do, because when people say data is a new oil, data actually is garbage. Most data is garbage. If you start off with an algorithm and you're given a very small amount of data, it's best for you to work on the small amount of data and increase it, like get in as much data as you want, but within the same context. People think that the more data you bring in, the better it will be for your algorithms, the better it will be for your data insight. But that's wrong, because data itself does not do you any good. I mean, if you bring in data from Facebook, you bring in data from your smartwatch, you bring in data from your Apple iPhone. These are three different sources. Facebook data has its own format. Apple has its data in their own format. Your watch has its own format. Now, the biggest job for you is to transform this data so that you make a new data format and bring them together. And transformation is very expensive. You have to hire data engineers to do the transformation part. You have to buy software tools who help you with the transformation part. Right now, there's a huge shortage of data engineers in the market. So if you can't find data engineers, then what's the point of getting in all that data? That will just remain there, and you'll just pay on the storage for that data. So think about consuming less data and producing better algorithms than consuming a lot of data and producing shitty algorithms. Right, okay. So how would you work with data? So what we're going to do, these are various techniques we use to work with data. We will go through all of them, not in a detailed way, but we'll tell you which technique does what. How do you work with different kind of data? So you have data labeling and annotation. So my startup, which I'm working with, is also based on this data labeling concept. Then you have data anonymization, synthetic data, data preparation, cleansing, and feature engineering. This is very important, very relevant to machine learning context. You have data wrangling, data mining, data warehousing. Data warehousing is very standard in all companies. Every company has a data warehouse department. My department also has a data warehouse team. And then you have data engineering, which is just a whole infrastructure, big cloud. In our class, we will learn data labeling and annotation. We'll show you, and we'll also have like a lab on how it's being done. We will have a lab on data anonymization. So Theo and Atika will help us with that. We'll show you how synthetic data is created. That's something you can try it on your own time. It's fun. Data preparation is everything, all of that. Plus feature engineering. So feature engineering will take a bit of more time. So we'll spend some time on feature engineering because this is something which we use a lot when it comes to machine learning. The better features, the better your algorithm is. Yeah. So we'll cover the first 4 points in detail in the class. Okay. So what is data labeling? Has anyone worked with data labeling before? No? Okay, cool. So why do you think, so when you make no, so if you go to if you open up your phone and you open up the camera app, right, and you start just looking around, nowadays I think almost all camera apps have this rectangular, so that kind of identifies where your face is. Some of them actually do that. So the rectangle immediately goes to your face and focuses on the face, and the light kind of shines outside that one. How can they do that? And of course, there's an AI algorithm behind it, but that's because the algorithm was taught beforehand how to identify that there actually is a human face over there. That process of teaching an AI algorithm that this is a human face and this is an object is called data labeling. What we do in data labeling is that we as humans, we are given a huge data set, like million images or 1,000 images, and we kind of go through those images and we specify that this, for example, is a picture of a dog and a human. And then we specify different attributes. That in this picture, if there's a sky, there's a dog, there's the water coolant, there are shoes, there's a tie on the human. It looks like it's a man and it looks like he's happy. These are different attributes we define on the image. This is something which have to do manually by humans. And then we feed it to the algorithm. The second picture also has a few attributes. It shows like it's a dog, it's a dog, it's an animal, blah, blah, blah. So you kind of specify different attributes. It can be as simple as saying it's a cat or a dog, and can be as advanced as giving more properties to the image. So those are the easy examples of data labeling. So what you do is you kind of have, this is one image, right? So you will get like thousands of images or millions of images. So you as a data labeler has to go through all of the images, specify all the attributes, and once you are done with the attribute job, you will then prepare the data set and feed it to your algorithm. Now the algorithm will know that all these images had these kind of attributes. So the algorithm can then predict on those attributes. So if you give a new image, completely new image, the algorithm will be able to predict saying like, I think in this picture, it's a man or it's a dog. And I think the person is wearing a tie, because that's something which you had trained the algorithm to work with. So there's a manual process of teaching the AI algorithms. This is called human in the loop. Has anyone heard of that? No, all right, okay. You have a question, or did you say like you have? Yeah, exactly like that. Exactly like that. The capture thing. So when you say like you're a human and you have to answer a few things like I don't know, this is a train or something. So at one side you are proving that you're a human, but on the other hand you're also training the data set by labeling them. And this is a train or not. It's a pretty cool concept. Like that's two things. One side it kind of trains, does data labeling for AI algorithms, and on the other hand it just kind of proves a person is human or not. Uh, so the funny thing is that the data labeling is such a big thing that there are it's a very brainless activity. Like all you have to do is to click, 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 and you have to specify the label. So you don't have to be educated. You don't have to have. You need to have domain experience, right? If I give you an images of satellite images, and I tell you like I have to explain to you like these are the images. You have to label this, this, and that. But that's all. But that's all the information you need. And once you get that information, then you just sit and then just do the labeling job. Um, and it's very popular in low income countries. So a labeling job, like if a person sits for an hour and labels, I don't know, 100 images, they will be paid like $1 dollar for that kind of work. Of course, it's very less for us, but I mean, for poor countries, it's actually pretty all right. It's it's still on a lower scale, but it's an easy work. You don't have to move a lot of physical boxes. You just do click on the computer. Now, this is so important because without data labeling, AI algorithms cannot function at all. We have created a lot of AI algorithms which pre-label the images for us, but data labeling is still like a huge element around it. So this was an example of an easy labeling, right? This is an example of a little bit difficult labeling, which is more like the driverless cars, how they do it. So the way autonomous vehicles label their data sets, like Tesla is doing their own, is that they collect the video feeds from different cars, and then there's a person sitting in, and the person will kind of um, draw some boundaries around it, boundaries around the car, boundaries around the tree, boundaries around a person, for example. They have to do it for every frame, every frame, every frame. And then the software learns and the software does it for them. So this is a human in the loop for the whole process. Any questions until now? No. So when you look at the amount of work which a developer puts in when it comes to AI, it's like I think 15 to 20% on the actual development of the model. So that's in the blue part. The red part is all about data. So you have data augmentation, data labeling, data identification, aggregation, and cleaning. But look at data labeling. That takes almost 25% of your time. So yeah, you're doing all things with data. But if you do not have a labeled data set and you have to do all data labeling, that will take most of your time. I do have an example of um, how this is done. I actually had a YouTube video, but it's not showing, it's not playing it. Okay, well, I'll share the link afterwards. What is data anonymization? Well, data anonymization is that you have a lot of sensitive data and you want to, you're not allowed to use that personal information data. Like Skatetaten has a lot of personal data about us. But when it comes to using machine learning algorithms, developers are not allowed to use that data. So what we have to do is to anonymize that data, hide our existing data, using data anonymization techniques. That was the data anonymization does. So when we do this, we can then use this data for our algorithms. So a person having what you do is you create a new identity, but that new identity is still linked somehow to the previous identity. So if you make sure that no one has access to the checksum or the key in between, then that data is totally anonymous. You're just generating random values. So ID will be a random value, name would be a random value, email, phone number, everything will be a new value generated according to your requirements. But you have to make sure that you are perhaps the only one who has the key who can transform the new identity back to the previous identity, because that's where data privacy comes in. For example, we did data anonymization in Router, and our law department did not approve it. They said that yes, you have anonymized everything, but still there is one person in the company who can use this data and track back and say, like, this anonymous data is actually that person. So GDPR kind of makes it harder to even work with data anonymization techniques. So we are considering how to actually fully implement data anonymization using GDPR compliance. Right. What is synthetic data? Synthetic data is when you produce data from nowhere. Like you probably have some data, right? You have like 10 rows in an Excel file or in a text file. And for your algorithm to work, you needed like 1 million rows. So you use a synthetic algorithm, and what that algorithm does is it generates the remaining entries for you based on the first 10 entries. That's synthetic data. You just create data out of thin air. It's used quite a lot, actually. It's used a lot when it comes to having control data set so your algorithms can function properly. Yeah, so I mean, the synthetic data actually uses a lot of AI to generate data for you. So you give it like a small data set, and then it will generate random sets of data, and then it will kind of populate. Yeah, it will just increase the data set size. Now, the next lecture is regarding feature engineering. But the thing is, feature engineering is so important. I don't think I'll be able to cover it today. So I propose we stop now, even though it's 10 more minutes remaining, but we stop with the presentation of this class, because I think we need more time to discuss feature engineering. We'll go through a few examples, and I'll show you how feature engineering is actually done. Yeah, so you have any questions for today's class or we'll tell you what the lab is for today. No questions? All right, so the lab, Theo has designed a lab for you. This is regarding data cleaning. But where did you happen to put instructions somewhere on Canvas or GitHub? Could you please share the link of GitHub on both Slack and Canvas as well? That'll be great. So take a look at the requirements for the lab. It's a very interesting exercise. It's a data set. You have to clean it using different features inside Python. And of course, like ask Artika, she's available online on Zoom, and Theo is available there. Yeah, just ask. So a question was asked if everyone can come to the physical class. I think you are allowed. Are you allowed? Yeah. Okay. I think you can come to the physical class. We are supposed to have like a hybrid lectures. So we will never force you to come to the class. I mean, it's just that if you feel like it's better for you to come here, just come here. So it will be both on physical inside the class and on Zoom too. I don't know actually how many limited. Yeah, a question was asked if there's any restriction on the number of people. I think I'll have to check that. Good question. I'll come back to you. Okay.